Hello everyone! Today I'll show you how to use the color sensor on the LEGO Spike Prime set to separate black and white using the RGB method. First, I'll create my variables for black and white. Next, I'll define a variable called total light, which I will use in a formula later on. I'm adding one more variable here just for control purposes. Now the first variables I'm entering represent the red light reflected off the black object. I'll set up similar variables for the green and blue readings from the black object. I'll do the exact same thing for the white object. I'll set up variables for the red, green, and blue light values bouncing off the white object. Alright, I'll head over to my code and set both the black and white variables to 0. I've now placed my total light variable. Let's set the safety margin to 20. Now I am showing you on the screen how to take RG breading. Next, I'll input the values I just read into these variables. For instance, when I placed the black object in front of the sensor, the red value was 40. Similarly, I checked the blue reading for the black object, which was 33. And the green reading was 30. You will need to enter the specific values you get from your own robot. These can vary depending on ambient light and distance, though I try to keep the distance consistent during tournaments. To prevent any minor errors, I've included a safety margin in my code, which I'll explain shortly. Now I'll create two new variables called total black and total white. I am going to transfer the sum of the values I just recorded into these variables. I'll combine the red, green, and blue values for black and do the same for white. For this, I'll use the addition block from the Operators tab. After nesting them, I'll place the red, green, and blue values for both black and white into the blocks. Then, I place these calculated sums into my total black and total white variables. Let me clarify something. If the robot can read these values automatically, why did I manually input them first? This is actually a precaution. In my workspace, the robot reads specific numbers, but at a tournament, the lighting conditions change. On competition day, I can quickly update these baseline numbers right there if needed. Recording these numbers helps me compare my practice environment with the tournament conditions. Technically, entering them isn't mandatory, since the robot can read and process everything on the fly anyway. However, doing this prevents me from panicking on competition day if the sensor readings suddenly look completely different. While I was explaining that, I continued writing the code. Now I reach the part where I actually separate black and white. I add the total black value and the total white value together, then divide by 2. This is the formula I will use shortly. I'll grab the addition and subtraction blocks from the Operators tab. I'll use these to set my thresholds for both colors. I've set my safety margin to 20, which is a moderate number. You could also use 10 or 30. I subtract this safety margin from the black value and add it to the white value. Now let's see how I execute this color separation command. For demonstration purposes, I set up a loop that runs until a button is pressed. For your actual competition runs, you can use run once or infinite loops based on your strategy. Next, I bring in the block that reads the raw values from the color sensor. The robot will now read the live values similar to what I manually entered earlier. Assuming my sensor is on port D, it will read the raw red, green, and blue light data. I forgot to place total light earlier, so I added it now. Earlier, I did some math to establish my color separation threshold using a safety margin. I subtracted the safety margin for black and added the safety margin for white. Honestly, the code would probably work even without this margin, because the total values for black and white are usually far apart. You can increase this safety margin to 50 or remove it entirely, but I prefer keeping it as a safeguard. For black, I set the condition so the upper limit of black is greater than the total light red. For white, I set its upper limit to be less than the total light. With this logic in place, my robot can now successfully separate black and white. To verify this visually, I'll have it print black or white on the screen. When it detects white, it will turn on the white light. When it detects black, since there isn't a black light option, I'll set it to glow purple. That's the basic logic. I'll just add an ending block. Don't forget to subscribe to my channel for more content like this. I demonstrated this RGB logic for separating black and white, but you can apply this exact same method to any two colors your robot tends to confuse. Make sure to subscribe for more tutorials like this. See you next time. Take care. Alright, let me test my code now. By the way, I lowered the safety margin from 20 to 10. Ambient lighting affects the readings. As I mentioned earlier, even if I don't set a safety margin, it will still make the distinction. I only add it as a minor precaution for when the values are extremely close. Just don't set the safety margin too high. For instance, 20 didn't work here because it's a bit dark and I'm not on the mat right now. I changed it to 10 and it worked. You can adjust this through trial and error based on your own environment. In a competition, you can easily fine-tune the safety margin with a few quick tests. Now let me test it. I am placing the white object and running the program. It detected the white color and turned on the white light. Let me stop it. Now let me place the black object and run it again. Yes, as you can see, my code works perfectly. Don't forget to subscribe to my channel for more content like this.